Hello everyone, hope you are doing well. In this video, I will explain about most important Java interview program called Recursive Fibonacci. So once development is done, I will debug. So let's get started. New class Recursive Fibonacci. Recursive Fibonacci. Select main method. To do means may we will implement later. Some functionality may we need to implement later is called to do. So first definition of Fibonacci. Definition of Fibonacci. A sequence where each number is the each number is the sum of the two two previous ones. Sum of the two previous ones starting from 0 and 1. Starting from 0 and 1. This definition is must understand. It is very, very important. Let's understand this. A sequence where each number is the sum of the two previous ones starting from 0 and 1. Starting from 0 and 1. So note what is recursive. So let's understand what is the recursive. As of now we are understand definition of Fibonacci. A sequence where each number is the sum of the two previous ones starting from 0 and 1 is called Fibonacci. What is recursive? So recursive recursive that means recall same method. Recursive that means recall same method. So let's understand through image. So see here, this is the Fibonacci of 0, Fibonacci of 0, 1, 2, 3, 4, 5, 6. So a sequence, this is the a sequence where each number is the sum of the two previous ones. This is a sequence, sum of two previous ones. So these two, 0 and 1 are the base case. Base case. This is the base case. Base case. Remember, this is the base case. So, suppose Fibonacci of 0 is the 0, it is fixed. Fibonacci of 1 is the 1. After that, we need to add sum of two previous one. Sum means plus only, right? So, I'm adding Fibonacci of 0, Fibonacci of 1. So, 0 plus 1, it is equal 1. After that, I need to add previous two. Now I am added 0 and 1. Now I need to add 1 and 2. In one place, 1 will be there. In 2, here 2 also 1 there, 1 plus 1, 2, right? Now we need to add Fibonacci of 3. 3 means previous of 2. Fibonacci of 3 means 1 plus 2. Now Fibonacci 4 means 2 plus 3. 2 is the 1, 3 is the 2. So 2 plus 1 equal to 3. Fibonacci of 4. Fibonacci of 4, that means 3. Fibonacci of 3 plus Fibonacci of 2. If Fibonacci of 5, that means 4 plus 3. That means Fibonacci of 4, see here 3. 3 plus Fibonacci of 3, that means 2 equal to 5. So this way too we can. So this is the diagram representation, understanding the Fibonacci. So we will develop to achieve this calculation. We will achieve once development was done. So to open STS, start the coding. So let's develop one private method. It is recommended to if any interviewer giving any program to write, then you can create one private method. It is recommended to. develop on private method, like a static method, private, static, recursive, Fibonacci, Fibonacci, suppose recursive, you can like this method. So now pass integer n. Suppose assume Fibonacci service we are calculating for the number 6. So integer n equal to 6, right? So first this Fibonacci series starts with 0, 1. What about if it is negative number? If it is negative number, we need to throw the error. So Fibonacci is not defined for negative numbers, right? For that, if n n so so n less than 0, that means so n value is greater than 0. That means so if n value is negative number, n value I am saying throw the exception, throw new illegal argument exception, illegal argument exception, add some command like Fibonacci. Fibonacci is not defined for negative numbers, not defined for negative numbers. After that, so we need to check base case. Base case. We are aware, right? Base case is nothing but here Fibonacci of 0, Fibonacci of 1. These are the base case. So, so both if Fibonacci of 0 or 1, then we need to return the same. If n so if n less than or equal to, so either equal or less than or equal to, less than equal to 1, then I am saying return n. I am saying return n. So so first one, if it is negative number, it will throw the exception. Second case, so if it is 0 or 1, it will return the same. So Fibonacci of 0, Fibonacci of 0 equal to 0, comma, Fibonacci of 1 equal to 1, right? Now, so let's add some command, return map result if available to avoid repeated calculations calculations. So like return map result if available to avoid repeated calculations. That means so we are checking contains key. Suppose this is the f of 0, 1, 2 like that. If it is same key repeated, suppose it is again repeated, then instead of again calculating, so just we are checking the key. This key is already available in the memory or not. If it is available, so return same. So for that input, let's add the map. Map. map of integer comma integer. So just map on it. Control Shift O for imports. So if map dot contains key is a n, then we are saying return map dot get of object means n semicolon. So now we need to calculate the actual calculation. This suppose these are the like a validations. So this is the negative number checking. This is the if it is one or base case. This is the duplicate checking kind of. So now calculate calculate the Fibonacci calculate the Fibonacci number and store it in map. Why we need to store in map? Like here we are checking the right contents. It is duplicate or not. That means this Fibonacci number already available in the map. Then only contents key we can check. So for that, so integer assume like it is a result. Recursive recursive factorial. I said like recursive that means recall the same method. So let's call the same method. So this is the method name. Method name we need to pass two parameters, right? N minus one. So map plus n minus one. That means suppose n minus one next plus n minus two. So now see integer result equal to recursive fab n minus one comma map recursive n minus two. So now put now map dot put we are saving. So key is a n, value is a result. Then return result, right? So this return type is integer. This is the previous sum of two previous. This is the sum of previous one. This is the sum of previous two. We are calculating. So this program is done. Let's develop some code to print. So let's take the map. Say map I am taking. Map equal to new as map. Semicolon. Let's take for int I equal to 0, I less than n, I plus plus. So let's print the result. System.out.println. So now some space method name. So now we need to pass I comma map. So see n equal to 6 we are taken. One by one it is iterating. Right? Post is the so 0, 1, 2, 3, 4 up to the 5 only. We are not added equal to up to iterate 5. Right? So control S. run a Java application. See, this is the expected. Post base case 0, 1. 0 plus 1 equal to 1. After that, 1 plus 1 equal to 2. After that, 2 plus 1 plus 2 equal to 3. 2 plus 3 equal to 5. Like this. So, if I want to debug, then let's add breakpoints. Here on breakpoint, I'm adding here 1. Add breakpoint. So, now let's debug. It will change to debug perspective. These are the debug options. Step into, step over, step return, step over. I'm selecting step over. So see now n equal to the initial value 0, 0. Now see now value is 6, I equal to 1. So next step over. So it is again checking. It is false, so it is entering into next if condition. So it is true. So then it is return. It is going to system.out.println. Now I equal to 1 is there. Next, so again, if you want to check the value of the n, next, if you want to check result, check the result. So step forward like this. This is the execution. See n value 3. We want to select this. See n value 3 like this. Next, step over, step over. So this way to we can debug. Step over. So we got this response 0, 1, 1, 2. Still it is yes. See, it is ended. So this is the response. So in this video we are successfully understand Recursive Fibonacci Java interview program. Thank you for watching. Please subscribe for more videos.